In a Fraunhofer diffraction at single slit of width 1 micrometer is observed with light of wavelength 500 nanometer. Calculate the half angular width of central maximum. So we know that half angular width of central maximum is equal to sine theta, which is given as lambda upon A. So here we need wavelength and slit width. So slit width is given as 1 into 10 to the power minus 8 meter, and lambda is given as 500 into 10 to the power minus 9 meter. We can put these values here. So sine theta will be equal to 500 times 10 to the power minus 9 divided by 1 into 10 to the power minus 8, which will be equal to 0.5 or 1 by 2. So theta will be 30 degree. Question number 2. A slit of width A is illuminated by the red light of wavelength 6500 angstrom. For what value of A will the first minimum fall at an angle of 30 degree, the first maximum fall at an angle of 30 degree. So here, for the first minimum, the condition is A sine theta equal to lambda. So we have to find out A. So it will be lambda upon sine theta. Lambda is given as 6500 angstrom divided by sine 30 degree. Sine 30 is half. So it will become 1.3 into 10 to the power minus 6 meter. Now we consider for the first maximum. So condition for first maximum is A sine theta equal to odd multiple of lambda by 2. So here 3 by 2 times lambda. So we have to find out A. So it will give 3 lambda divided by 2 sine theta. Now we put the value 3 into 6500 times 10 to the power minus 10 divided by twice of sine 30 degree, that is 0.5. So this will come out to be 1.95 into 10 to the power minus 6 meter. Now let's consider next question. For what distance is ray optics a good approximation when the aperture is 4 millimeter wide and the wavelength is 500 nanometers? So here we are given A equal to 4 millimeter, that is 4 times 10 to the power minus 3 meter, and lambda is 500 nanometer. So we can write it 500 into 10 power minus 9 meter. Now here we have to find out Fresnel's distance. So df is equal to a square divided by lambda. So a square means 4 into 10 to the power minus 3 squared divided by 500 times 10 to the power minus 9. So if we evaluate it, so it will come out to be, we can just check it. So this is 16 into 10 to the power minus 6. And from here, this will become plus 9. And this is 500. So let's simplify it further. So it will become 1, 6, 1, 2, this is 9. So clearly, $16 followed by 000. So 16,000 divided by 500. So 1, 2. So it will be 32 meter. Now let's go to next question. Next question says, two towers on top of two hills are 40 kilometer apart. So this is one tower, this is another tower, and distance is 40 kilometer, but there is halfway obstruction. So this is 20 kilometer, this is 20 kilometers. Let's read the question fully. The line joining them passes 50 meter above a hill halfway between the two towers. So here this height is 50 meter, this one. So if this is 50 meters, so this will be taken as aperture. So A equal to 50 meter. And this portion from here to here means 20 kilometer will be taken as Fresnel distance. ZF or DF is equal to 20 kilometer. That is 20 times 10 to the power 3 meter. So we have to find out wavelength lambda. We know the formula df, original distance, is given by a square by lambda, or lambda equal to a square divided by df. We put the values a square, that is 50 square, divided by df. Df is 20 into 10 to the power 3. So let's evaluate it. So it will be 2500 divided by 20, 1, 2, 3. So 1, 2. Now this will become 1 by 8 meter. So 1 by 8 meter means 100 divided by 8 will be equal to 12.5. So this is 12.5 centimeter, which is our answer. Thank you for watching.